Hi, I'm Cheun, and today I will talk about what is Moscap. I will proceed in this order: what is Moscap and how Moscap works, and Moscap CV curve analysis, and last, there is two measurement method: high frequency, low frequency, and additionally what is deep depletion state. First, what is Moscap? This figure is about MOSFET, but today we talk about in this structure: metal, oxide, and semiconductor, and this structure is called Moscap. Here is two figure, and first, this is about typical capacitor like metal, oxide, metal structure, but the most capacitor is like metal, oxide, semiconductor, and semiconductor is added instead of the metal. And here is the two formula. This is about typical capacitor value formula, and this is about most capacitor value formula. But I will explain about this formula later. And let's talk about how Moscap works. There is three major state, and I will explain about first accumulation state. This first figure is about structure of Moscap, and when we apply the negative voltage at the gate, the holes are accumulate at the oxide state, oxide interface, and the holes are accumulation like this, and the capacitor value does not change because there is only an insulating layer like oxide structure. And this graph is about charging graph, and here is the plus charge and minus charge. And let's talk about depletion state. When we apply the positive voltage at the gate, there is only depletion state remains at the nearby oxide interface. So we can see that the depletion layer and this depletion layer acting like insulating layer. So the capacitor value are changed, and this is about when we get the depletion state, we can calculate using this formula. And here is the charging graph, and this is about the depletion layer. And last is about inversion state. When we apply the strong positive voltage at the gate, the minor carrier, the electrons are gathered at the oxide interface. So when the electrons are accumulate at the oxide interface, that acting like negative channel. So we can see the charging graph, and here is the inversion layer, and we know that the electrons are accumulated at the oxide interface, and there is only remain the depletion layer like fixed charge. And let's talk about Moscap CV curve. And here is the CV curve, and I will explain like three major ways. The first is strong accumulation, and this state is I mentioned about previously when we applied the negative negative voltage at the gate. We know that the capacitor value does not change because there is no insulating layer. And when we increase the voltage like this, we can see the capacitor value are decreased because when we get the positive voltage at the gate, the depletion layer are increased at the oxide interface, so that acting like new insulating layer. But why the capacitor value is decreased? Because the insulating layer acting like parallel connection with oxide layer, so the capacitor value is decreased. I mentioned about that previously, maybe in here. So the capacitor values are decreased. And when we apply the strong positive voltage at the gate, there is two ways about the capacitor value, and this is about low when we measurement the capacitor value using low frequencies, and this is about high frequency. Why there is two ways about capacitor value? Because when you apply the high frequencies, the interface of electrons do not react at the high frequencies, so the channel of minus channel are not react, so the capacitor values are maintained like previous state. But so simply I explain about that, like where you so like yeah, that's it. But strong inversion layer is generate, but we can see that two ways about capacitor value when we use high frequencies or low frequencies. And additionally, I explain about the deep depletion state. This graph is about Moscap CV curve, like this graph, but we can see the we can see the capacitor value are more decreased than this state, because when we measurement the capacitor value, we both use DC bias and AC bias. But when we using the too fast DC bias, the minority carrier do not react, so the depletion layer are increased and the capacitor values are more decreased about the generate the insulating layer. So today's lecture is here, and thank you for listening.